Welcome to math. We're going to get started on our new unit. It is called Working with Graphs. We're going to do the Getting Started section and then we'll move on to the actual lessons. So what I need you to have is either a highlighter or a pencil or a different colored pen, something, because you're going to be adding some visual detail to some of the graphs that we're going to be working with together here. So here it says Landon is a graphic designer and he creates brochures and newsletters for clients. One brochure Landon created shows this graph about how the contributions to a charity are spent. So here's the graph. This is what it looks like. You should have the same thing on your page. So this portion of this circle graph or pie graph is that community programs make up about 85%. Administration is 8%. And fundraising is 7%. And this is how the contributions are spent. Now remember, this total has to be out of 100. All right. So why are graphs used so often in brochures and newsletters? So basically, to visually represent data. Quickly and in a format that's easily understood. So it says here, choose a graph. What might you or a designer use it? When might you and the designer use it? So let's say you're going to use a bar graph. So because it's simple, and displays data neatly, and easily. Or you can use a line graph, whatever. Move on here. So it says here on the side that you'll need a ruler and a protractor. You will definitely need a protractor. If you don't have one for this section, that's fine, but you will need it for upcoming sections. So that means if you have a protractor at home, by all means bring it. If you don't, we've got a few others, and we got some that we can definitely makeshift to use one. So it says here on the side, what do you think this bar graph might be about? So we're going to take a look at it. Make it a little bigger so we can see. Now this type of graph is a little different. It is a vertical bar graph. It's on its vertical axis rather than on the horizontal axis like other graphs. And the way you can tell is because the bars are going across like this. So now things are a little bit different. Like this is still the x-axis and this is still the y-axis, but the only thing is when we're trying to identify the independent variable is the one that you can control and the dependent variable is the one that you can't control. So on this particular graph, this is the independent variable because you can control what months that you're going to be taking the information. And the dependent variable is the one where you don't know how many people are going to be selected or tallied or whatever for those particular months. All right, so we need to give this particular graph a title. It says right here, it says label the vertical axis and title for the topic you named in part A. So let's call this people who go on vacation. And then here on the side, we can call these vacation months. All right. So now, whoops. It says, about how many more people were there in April than in the 2 months before? So here we got April. And we're talking about the 2 months before. So here we got February. So about how many more? We're just doing an approximation based upon what we have. So here's April. It's at the 600 mark. We've got February, and it's about at the, I guess, the 450 mark. So we can assume that if we take 600 subtract 450 would be about 150. So let's put that in there, 150. So the 2 months after, so here we have April, and we're looking at the 2 months after. So this is 600, and then this one we're thinking, it's about 350. So approximately 250 people after. Oh, I forgot to put up here, what do you think this bar graph might be about? People going on vacations. It might not necessarily be that, but that's what we're going to indicate. All right. So now Rob surveyed grade 11 students. He asked about their favorite type of movie. He recorded the results in the chart on the left. So we're going to create a bar graph for the data. You need to put the categories along the horizontal axis. And Rob decided to rent a movie to watch with some friends from school. What type of movie would you suggest? Justify your decision. So if you look here on the side, we've got our data table. I know it's not the greatest copy, but it does say type of movie and number of students. So we have romance, comedy, action, drama. And the number of students for romance, there were 9. Comedy, there was 21. Action, there was 24. And drama, there was 6. So remember when we were doing the introduction to graphing lessons last week, that whenever you're creating a graph, that there should always be a data table that's associated with it. So that way we know what is what, and that way you're keeping your information that you're representing on the graph as accurate as possible. So we are going to make this a little bigger so you can see it. It's already titled for us, favorite type of movie. We have number of students for this side, and then we've got type of movie. Oh, I'll move it up a bit here for the bottom. Now, when we're creating our bar graphs can be side by side, meaning that they can touch, but they can also be separated, just like the top one in the people who go on vacations bar graph that we just did. So in this case, because we're looking at number of students, we're going to create our scale here of how we're going to measure things. So always in the corner is 0. And then we're going to call this one 10. And this one's going to be 20. And this one's going to be 30. Just to make things easier, because then it looks like we're going 0, 5, 10, 15, 20, 25, 30. On the side, on the bottom, we're going to create our categories. So we have romance, and I'm just going to shorten them. Romance, comedy, action, and drama. Now, according to the data table that's on the left, we know that romance is about 9 people. So we're going to put it about, let's make this a little bit better. You can use a different colored pen on your piece of paper. About there. Oh, might help if I put it in the right spot. So that's romance, approximately 9 people. Comedy is 21, according to the data table. So 21, so it's just a little bit past. Action is 24, so So not quite up to the 25 mark. And then drama is 6. So just a little past the 5 mark. All right. So once you've got that filled in, now we can answer our question based upon the information that we drew in the bar graph here. So it says that Rob decided to rent a movie to watch with some friends after school. Which type of movie would you suggest based upon the information that's here in this bar graph? So you could justify with your own opinion, but then again, if you're just going by the information here on the bar graph, you would say that an action movie would probably be appropriate. Whoops. An action movie because many people prefer actions. Action movie. All right, moving on to our next one. So it says here, draw a horizontal number line from 0 to 100, label the scale by 20s, then plot 27, 51, and 90. So first of all, a scale is the number represented by each unit in a graph. And you've seen scales pretty much all the way through school. Scales can go up by 2s, by 5s, by 10s, whatever. So here we're going to create our line graph. You can make yours as straight as possible. Mine's going to be free-handed because I don't have a ruler to use on here. And it's going to go from 0 to 100. So here I've got 0, and I know way over here will be 100. And so I'm going to go by 20s. So I'm going to say 20, 40, 60, 80, 100. So it does ask us to plot 27, approximately where I think 27 is going to be. If I'm looking here and I estimate that 30 is going to be about here, then possibly 27 may be about here. So this would be 27 for me. I need to plot 51, so if I'm thinking 50 is about here, then 51 is probably just going to be a little bit past it. And the last one's 90, so I'm thinking 90 is about here. So I'm going to plot 90 right there. And again, this is all about estimation, as long as it looks reasonable. Last part on this page, it says calculate each percentage of 360 degrees. So we want 15% of 360 degrees. So remember, we've done this part before where we're taking a percentage of something. And remember, we change the percentage into a decimal, the of changes the times, and this stays as is. So this becomes 0.15 times 360. And then we record our number as 54. And then we do the same thing over here on this one. So we're going to change 5% into a decimal. Of changes the times, 360 stays as is. We multiply those two together and we get our answer of 18. Now this information comes a little bit more relevant a little bit later. All right, you're going to flip the page. We're going to continue on here. So it says here, John works at a camp in Canmore. He used this line graph to schedule events for tomorrow. It was 16 degrees Celsius at 9 p.m. and plot this on the graph. So at 9 p.m., here's 8 p.m., here's 9 p.m., so we're going to say it's 16 degrees. So we're going to put the dot right here. So you're going to do the same thing with yours. And you're going to connect those lines together. So in which hour was the temperature warmest for swimming? So where was it the warmest? So from what time to what time? So you're using the information on the graph here in order for us to determine that answer. So here is the highest temperature, which is at 28 degrees. And so we know that between 3 p.m. and 4 p.m. it was probably the hottest. 3 p.m. to 4 p.m. When did the temperature decrease? Well, it started to decrease from, and we're taking a look, so from 4 p.m. all the way to 9 p.m. when it was last recorded. When did it increase? So it increased from 10 to 12 p.m. 10 a.m. to 12 p.m. Sorry, 10 a.m. to 11 a.m. 10 a.m. to 11 a.m. And then from 1 p.m. to 3 p.m. And when did it not change? That means that it plateaus, it's flat. So between these 2 hours, so we've got 11 a.m. and 1 p.m. And then again, between 3 and 4 p.m. Now there are some things on here that I want to point out on this particular line graph. So here it says a zigzag mark is used on each axis to show a break from 0 to the first label. So here's that zigzag mark right there. When we use a zigzag mark, it's only to show a jump from 0 to 10 because that meant that we weren't recording any data there, so it wasn't relevant at that time. Same thing between 0 and 16 degrees. We weren't recording any data during that time, so it wasn't relevant. So we have that break to indicate that the information wasn't relevant during that time. Info was not relevant. And not recorded. Keep in mind though, if you're doing a line graph and you're doing an experiment or whatever it is, you're collecting data and you have to collect it from point 0, that means you still need to include that information. That means that there will be no break. But all graphs are different. All right, we're going to take a look at this one. Number 6. What is the measure of the angle in the circle graph? Complete the legend to tell what each sector might represent. So we know that this circle graph, it's a graph that shows how parts make up the whole. And just a reminder that in this circle graph, this has to equal up to 100% in percentages. So I don't know how great your copy is, but this is 108. This is 36. We don't know what A is. We have to figure that out. And this is 54 degrees. So D here is 54 degrees. Actually, I'll put it in black. So we have to determine the measure of the angle in each circle graph. The easiest way to figure this out is that we know that in a complete circle, and you might want to write this down as a hint, in a complete circle, the degrees equal 360 degrees. So that means that all of these sectors, when we add them up together, they have to equal up to 360 degrees. So we know in sector A, we don't know anything about it. We'll figure that out. Sector B is 36 degrees. Sector C is 108 degrees. And sector D is 54 degrees. So if we take that information, we take 36 degrees plus 108 degrees plus 54 degrees, and we add all that up, we'll find out that we have 198 degrees so far. But we want to know what the missing one is, the missing sector is. So we're going to take 360 degrees of the total of that circle and subtract 198 degrees of what we do know, and what our leftover is the answer. That's what that sector A is going to be, 162 degrees. So over here on the side it says a legend, an explanation of the symbols or colors in a graph. So because especially when you're dealing with black and white, you might want to use different patterns in order to indicate what each of them mean. So for instance, looking down here at this particular type of graph, or this rectangle, we've got different patterns that are going on here. Who knows what they represent? But if we've got a legend that tells us what they represent, then we have a better idea of identifying them. All right. Number 7, it says, what percent is each rectangle compared to the large rectangle? So first of all, we need to know like how many squares are in this complete rectangle. And if you count, we've got 1, 2, 3, 4, 5 here on the side. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here on the top. So 5 times 10, we know equals 50, so that there are 50 squares here. So here it says what percent is each rectangle compared to the large rectangle. So we want to know how many white, or the percentage of white to the rest of the rectangle. So we have 2 out of 50. Okay, so 2 out of 50, not 2 of 50, but 2 out of 50. So 2 out of 50 is like saying 2 divided by 50. And so when you use your calculator, so 2 divided by 50, you're going to get 0.04. We want to change that into percent, so we have to times by 100. So 0.04 times by 100 equals 4%. So now if you just want to do this really quick, you don't have to write down all this information. You're just going to put down what it is. So we've got black, so how many do we have of black? 1, 2, 3, 4, 5, 6, 7, 8. So we're going to take 8 divided by 50, and then we're going to times by 100 in order to get our answer, which is going to be 16%. Same thing with the light gray. You're going to count the light gray. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divided by 50 times by 100 in order to get your answer, which is 20%. Do the same thing with the spotted. Spotted ones are all these ones. So we've got 10, 25. So 25 divided by 50 times by 100 equals 50%. Striped, we've got 5. 5 divided by 50 times by 100 equals 10%. And then the whole large triangle all together out of everything. So 50 divided by 50 equals 1 times by 100, which equals 100%. All right. If you are complete all of this, and you should be because you did it with me, but you are not complete the questions from last week for lessons 1, 2, 3, 4, and 5, please use the remainder of your time to get caught up on those. You will need to log into the computer and go onto Teams and check out everything on there. The dates are there from last week. So I will see you soon, hopefully, and take care.